Do you know that Hudi 1.0 can significantly improve your data lake read and write performance by leveraging powerful features such as record index, secondary index, partial updates, and more? My name is Shiyan. I work as a data architect. I'm also a PMC member of the Apache Hudi open source project. In the past few years, I have led and contributed to core Hudi development. I'm super excited to launch this blog and video series called Apache Hudi does XYZ. In this series, I will illustrate the core Hudi concepts and capabilities, and share practical guide and examples to help you learn Hudi more effectively. In this first video, we will explore Hudi's file pruning capability and see how it improves read performance. Let's get started. In a typical data lake table, you have multiple partitions that physically separate data files on storage. It's simple, but it's also very limiting when it comes to speeding up queries. Now, Hudi as a lakehouse framework defines a table format that uses metadata to describe these partitions and data files. This helps query engines efficiently scan just the data they need. The metadata lives in a .hudi directory under your table space path. Inside this directory, you will find various types of metadata for different purposes. You will have a hudi.properties that contains table configurations. There is a timeline subdirectory with transaction logs that record all the changes made to the table. And there is a metadata subdirectory that serves as what we call a multi-modal index. This is our focus today. It offers a wide range of indexes to improve the read and write performance on Hudi tables. So what we see here is how Hudi organizes the metadata, which is the key ingredient that turns plain Parquet files into a lakehouse table for efficient reads, updates, and deletes. How does a query engine make use of Hudi's metadata table? The core logic is in the Hudi integration component for the query engine. The overall process is that the query engine will need to read a metadata table and eventually fetch a list of files to read for the given SQL query. The metadata table contains many different index components. That's why we call it the multi-modal index. Files is the index that provides partition and file lists. It will first return a list of partitions available in the Hudi table. Obviously, not all partitions are relevant to the query. The partition stats is another index that helps reduce the partition list using partition level statistics. It'll skip those out-of-range partitions and produce a pruned partition list. With this shortened partition list, we can ask files again to provide a list of files under those partitions. Similar to partition stats, colon stats contains file level statistics to help skip those out-of-range files and produce a pruned file list. Finally, the pruned file list will be sent back to the query engine for further processing. Thanks to the reduced number of files to read, the query engine can run much faster to get results. Since Hudi 1.0, the files, partition stats, and colon stats are enabled by default. You can configure the Hudi table to only build indexes for the frequently used columns in your SQL predicates. That will precisely improve your most common analytical queries without the overhead of maintaining indexes for too many columns. We've just had a glimpse of what Hudi multi-modal index can do. Zooming out to a higher level, Why would you use multi-modal index with Hudi 1.0? The first benefit is obviously to improve performance. This is applicable to both read and write operations. There are other aspects such as scalability, extensibility, and maintenance, where the multi-modal index would also provide great benefits. I hope this video has been helpful for learning the file pruning feature in Hudi. Please also check out the corresponding blog for more details and examples in the comment section. In the next video, we will continue to explore more powerful indexes supported by Hudi. I will see you in the next one.